from the data.
Now let's talk about the decision boundary of a perceptron, which is one of the most important concepts in understanding how neural networks classify data. A perceptron takes multiple inputs, multiplies each input by a weight, adds them together, and then applies a threshold bias. Mathematically, the decision rule looks like this: W1x1 plus W2x2 plus b equal to 0. This equation represents a straight line in a two-dimensional space. That line is the perceptron's decision boundary. It separates the input space into two regions: one side where the perceptron outputs 1 and the other side where it outputs 0. By changing the value of the weights W1 and W2, we change the slope and the orientation of this line. By adjusting the bias P, we shift the line up or down, left or right. This is what makes the perceptron more powerful than the MCP neuron. Instead of having a fixed boundary, the perceptron learns the best boundary during training. It can tilt the line, move it around, and position it exactly where it can best separate the classes. So, in simple terms, the perceptron decision boundary is a straight line whose position and angle are determined entirely by the weights and bias. This flexibility is what allows perceptrons to model many linear classification problems.